Welcome back to the Moralis channel. My name's Ash. If you're going to make a game that players are going to want to flock to, it not only needs to be fun, but the gameplay mechanics need to be designed to be fair and balanced, and that's especially true for a Web3 game where potentially valuable tokens are going to be at stake. Previously, we've integrated Moralis into this bank panic game to use a Web3 wallet login and also check a user's NFT balance in order to grant them access or deny them access. In this video, I'm going to show you how to create a play-to-earn game mechanic that's going to integrate crypto tokens into this demo phaser game that we've been working on in the previous videos. You don't need to have watched those previous two videos, but I suggest that you go and grab the code base from the link down in the description so that you can follow along. The first thing we need to do is understand the smart contracts that are going to run and balance the economy of our play-to-earn game. Initially for this demo, I'm going to be designing the game to require that the player is paying to play. So they'll be staking a small amount of this native token that we're going to be creating in order to access the game. Because to keep things simple, for the player to have some tokens at stake is going to be important in balancing the game economy. In the future, I want to make this game a free-to-play so that there's no barrier to access, which will attract as many players as possible. But achieving this is going to require more complexity on the contract side to balance the game economy properly. For now, we'll stick to a pay-to-play model, but we're going to keep the bar of entry as low as possible. The important game events the contract needs to take care of are players losing, players winning, and the exchange of the tokens between the player's wallet and the game's admin, which will be a bot made of a few simple cloud functions, and then the game's treasury wallet. So if the player beats the game, then they'll get sent the tokens that they won during the game and their tokens that they staked. However, if the player fails, then they lose their tokens that they've staked in order to play, and those tokens get put back into the game's treasury. As the player progresses, the player collects more tokens, but the game's difficulty increases, and thus the chance of the player losing all those tokens that they've earned. What we're trying to do is incentivize fun through reward, but create a difficulty curve that means that the game's economy isn't just destroyed and it's all fair and fun. This is a very basic example of a game economy that demos the principle of balancing through its game mechanics. The way we're going to be achieving all this is by mimicking an escrow flow in our smart contract and using the Moralis API to interface with it from the game's front end. We're going to require two smart contracts. They're very simple, but one is going to create our game token, which we're going to call gold, so gold tokens in our bank panic game. It's going to be fungible using the ERC20 token standard. And then a second contract is going to manage the movements of those gold tokens from the player to the game's treasury and back again in a way that is going to be as trustless, permissionless as possible. The game token contract itself for the ERC20 tokens, for the gold tokens, is very simple. We're just minting a supply of 100 gold tokens and sending them to our currently acting treasury address. We're piggybacking off of the OpenZeppelin's ERC20 contract. This constructor is going to be run once when the contract's deployed, and all the code here is going to mint 100 of our game's gold tokens and then send them to our game's dev wallet. In this case, it will be acting as both admin and game treasury reserve for demo purposes for simplicity. To note though, we're also going to be inheriting ownable here, so that this is the possibility to be able to renounce the ownership of the contract so that nobody can own the token contract. And we're also going to be doing the same for the second contract. The P2e Game Contract is going to act as escrow for our gold tokens between our player and our game dev treasury. When a player starts a game, they're going to deposit a gold token in order to earn more. That's the incentive to play. If a player then wins, they're going to be rewarded with the token that is staked within escrow and also tokens that they've won in the game transferred from the game's treasury reserve. However, on the other side, if the player loses, then they're going to have their tokens returned to the game's treasury. So let's go ahead and deploy our fungible gold token smart contract first. Open Remix in your web browser at remix.ethereum.org. Click on New File, give it a name, anything you like, but we're going to be calling it gametoken.sol. Paste in the code from the Git repo in the link in the description, or just pause this video and copy it for yourself. We could do this via Truffle, but for a tutorial to demonstrate the code, Remix is actually just a visually way better way to communicate. Go to compile. If it's not already auto-compiling, then just go and hit compile. compile the contract. Finally, we're going to deploy our contract, in this case to the Polygon testnet Mumbai. Make sure that you're using injected Web3. I'm using MetaMask connected to the Mumbai testnet with some testnet Matic tokens for the gas. So in this contracts constructor, it's allowing us to stipulate the name and the ticker symbol for our game token. So once you've done that, hit deploy. I'm going to go to MetaMask and import this new custom token, this gold token, into my MetaMask so that we can see the balance. Copy and paste the contract address and hit add custom token. And there we go, we've successfully deployed our custom game token. Next, we want to use the tokens in circulation that we just created in our game's economy, which we'll keep very simple. Again, we'll just create a new file and either grab the code from the repo or, like I said, just pause this video and copy it here. We're then going to copy the contract address from the ERC20 token contract that we just deployed and paste it into our P2e contract here. Then we're going to do the same as we just did to deploy this contract to the testnet. We've got both our game's Play2Earn contracts deployed, so let's walk you through how the game is actually going to work, and I can do that via Remix, just using the functions here in the interface. But the first thing to note is that we're going to need to mimic a player who's already got the gold tokens. When you actually go to production for this game, you could have like 10,000 players get distributed tokens just for playing. But here, for this demo purpose, we're just going to use this contract to transfer tokens from the current treasury holder into a demo player wallet. So we're going to transfer 10 gold tokens into this player's wallet. So let's say our player has just arrived at our Bank Panic Games interface. They'll authenticate via MetaMask. They're then going to be asked to approve an allowance of their gold tokens into the escrow contract. Nothing has moved yet from the player's wallet. They've just approved an allowance. Then we're going to have the player start a game. The game's code is going to create a game ID, provide the treasury address and an amount that needs to be inserted in order for the player to play. This amount within the allowance that has been given by the player is then going to be transferred or staked into the P2e Game Contract until a game is complete. If the player wins, the Moralis API will call this function, which then releases the staked tokens plus any winnings to their account. But then if the player loses, the Moralis API will call this function, which transfers the staked tokens back to the game's treasury. This contract keeps a track of each game's balance and is only going to release funds to the winning party programmatically should certain conditions be met. Something we need to consider when we're creating a play-to-earn game is creating a fair game that aims to be as closed a system as possible, because you don't want anyone human owning one of the contracts and being able to act upon it in a malicious way. And to achieve this, you want to have the ownership of both contracts in the play-to-earn game to be renounced, so they're set to a zero address, and the only entity that can act on the functions is the admin wallet that acts programmatically dependent on game logic. And then further to that, the game's treasury, rather than just being a wallet with a set of private keys attached to it, could also just be another contract to whom the ownership has also been renounced. But it could also just be a wallet where the keys are, say, lost or unknown to any human. Although in this demo I'm using the same address for the treasury and the admin wallet that's moving the coins in and out of escrow, ideally you'd have these separate. And this admin wallet will be a collection of just Moralis functions acting programmatically on logic stipulated game outcomes. Annoyingly, that is all I got time for today. There is so much more exciting knowledge here to explore that I can't wait to share with you, but what I've shared with you today is the foundation of a Web3 play-to-earn game. In the next video, I'm going to show you how to fully integrate this play-to-earn mechanic of the smart contracts into the front end of the Bank Panic game using the Moralis API. Until then, thanks for watching and happy biddling.